Imagine, if you will, a world utterly alien to our own. This is Earth, 422 million years ago, during a chapter of its history we call the Silurian period. We are not standing on solid ground but floating in the warm, shallow waters off the coast of an ancient landmass named Avalonia. The air above carries a faint, sharp smell of sulfur, a chemical signature of the planet's volcanic activity and burgeoning life. The sun is hot, and the sea levels are extraordinarily high, maybe even 200 meters higher than they are today. This global flooding has turned continents into vast archipelagos, creating endless coastlines and shallow marine environments where life is about to take a spectacular leap forward. The very face of our planet is in motion, though at a pace way too slow for any single lifetime to perceive. The great continents are drifting. The vast Iapetus Ocean, which once separated the landmasses of Laurentia and Avalonia, is slowly but inexorably shrinking. These two continents are on a collision course, a kind of geological dance that will, over millions of years, crumple the crust and raise the mighty Appalachian Mountains. Below us, the seafloor spreads to create a new, widening body of water, the Reich Ocean. It is a time of immense geological transformation, a planetary reshaping that sets the stage for the evolutionary drama about to unfold in the waters around us. Let us dip beneath the surface. The water is astonishingly warm, like stepping into a hot tub. This is a tropical paradise, heated by a greenhouse climate far more intense than our own. Near the equator lies Laurentia, the core of what will one day become North America, while the supercontinent of Gondwana sprawls near the South Pole, its edges fringed with ice. This global warmth is a crucial ingredient, providing the energy needed to fuel an explosion of life. After a devastating extinction event at the end of the previous period, the Ordovician, the survivors now find themselves in a world of opportunity, a vast, warm cradle ready to nurture new and complex forms. This is a world almost entirely dominated by the ocean. While the land is largely barren and silent, the seas are teeming with activity. The Ordovician Silurian extinction cleared the slate, wiping out many dominant species, and opening up ecological niches for new creatures to fill. It was a reset button for life on Earth. Now in these sunlit shallow seas, evolution is experimenting with new body plans and new ways of living. The stage is set, the waters are warm, and the first actors in a new evolutionary play are beginning to emerge from the wings, poised to build a world more complex and vibrant than ever before. Here, in the clear Silurian waters, we find something remarkable. The first large-scale reef ecosystems in Earth's history. These are not the familiar coral reefs of today, with their branching structures and vibrant colors. Instead, they are strange, otherworldly constructions. Rocky labyrinths, built by organisms that are now long extinct. They form massive structures known as bioherms, which could grow to be hundreds of meters tall and stretch for kilometers across the seafloor. These reefs were the bustling cities of the ancient ocean, providing shelter, food, and a complex habitat for a dazzling array of creatures. It is here that the blueprint for future marine communities was first drawn. The primary architects of these magnificent structures were creatures called stromatoporoids. Though they look like strange, stony mounds, they were actually a type of primitive sponge. They grew layer upon layer, creating enormous domes and thick pillar-like formations that became the very foundation of the reef. Working alongside them were the first true corals. There were the tabulate corals, which built colonies of tightly packed hexagonal cells, resembling a petrified honeycomb. And then there were the rugose corals, sometimes called horn corals, which grew as solitary, cone-shaped individuals that could reach up to a meter in length. Together, these organisms formed a solid, enduring framework. Adding to the complexity of this underwater architecture were the bryozoans. These were colonies of thousands of tiny individual invertebrates, all living together and secreting a shared calcified skeleton. Their colonies grew into delicate fan-like shapes or robust boulder-like masses, filling in the gaps between the larger stromatoporoids and corals. They acted like cement, binding the reef together and creating countless nooks and crannies for smaller animals to hide in. This intricate tapestry of builders created a three-dimensional world, a significant step up from the flatter seafloor ecosystems that had come before it. The reef was a fortress of life. These Silurian reefs represented a monumental leap in ecological complexity. They were self-sustaining biological engines, concentrating nutrients and providing a stable environment in the ever-shifting ocean. On and around these structures, life flourished. Brachiopods, shelled animals resembling clams, carpeted the surfaces. Crinoids, or sea lilies, waved their feathery arms in the gentle currents, filtering food from the water. And snails, the gastropods, slowly crawled across the stony surfaces, grazing on algae. This was a complete, functioning ecosystem, a model of interdependence that would be replicated, with different actors, in the oceans for hundreds of millions of years to come. Among the reef dwellers and filter feeders, formidable predators patrolled these ancient waters. The undisputed apex predators of the Silurian Seas were the eurypterids, or sea scorpions. These were not true scorpions but giant arthropods, some of which reached terrifying sizes. The largest, like Pterygotus, could grow to be over 2 meters long, making them the largest arthropods that have ever lived. With powerful swimming paddles and a pair of large grasping pincers at the front of their bodies, they were swift and deadly hunters. They would pursue and capture anything they could, from trilobites scuttling on the seafloor to the newly evolving fish. Sharing the seas with these fearsome hunters were the cephalopods, the ancestors of modern squid and octopuses. In the Silurian, many of them still lived within protective shells. Some, like Dawsonoceras, possessed long, straight, cone-shaped shells, making them look like swimming spears. They propelled themselves backward by shooting jets of water from their bodies, their tentacles trailing behind to snatch unsuspecting prey. Others were beginning to experiment with coiled shells, a design that offered greater strength and maneuverability in the water. These shelled cephalopods were intelligent and active predators, rivaling the sea scorpions for dominance in the food chain. But the most significant evolutionary story of the Silurian was unfolding among the vertebrates. This was the true dawn of the age of fishes. For millions of years, the only fish had been jawless. Many of these, known as ostracoderms, were covered in heavy, bony armor, plating for protection. Some, like the heterostracans, were little more than armored heads with a propulsive tail, filtering food from the seabed. Others, the cephalaspids, were more advanced, possessing the first pectoral fins, which gave them greater stability and control as they swam. These armored jawless fish were everywhere, a testament to an early, successful design. And then came the revolution, the jaw. Evolving from the first pair of gill arches, the jaw was a biological innovation that changed the world forever. The first jawed fish, the placoderms, appeared. These were also armored, but now they possessed a powerful bite. An early example, Entelognathus, was the first creature to have a face we might recognize, with a distinct jaw, nose, and eye sockets. Alongside them swam the acanthodians, or spiny sharks, who combined a cartilaginous skeleton with bony spines. And most importantly, the first true bony fish, like Guayu, emerged, laying the foundation for the two great lineages that dominate today: the ray-finned fish and our own direct ancestors, the lobe-finned fish. While the oceans were a theater of dramatic change, an even more profound revolution was quietly beginning on the barren continents. For the first time in Earth's history, life was making a permanent move onto land. The pioneers of this great invasion were not vertebrates, but arthropods. Driven by the search for new food sources and a desire to escape the crowded, predator-filled seas, these creatures ventured into a world of harsh sunlight and open air. Early scorpions, still semi-aquatic, developed book lungs that allowed them to breathe air, perhaps returning to the water to mate but spending more and more time ashore. Following closely behind them were the myriapods, the ancestors of today's centipedes and millipedes. Fossils of creatures like Campacarus, no bigger than a paperclip, show that these multi-legged crawlers were among the very first animals to establish a fully terrestrial existence. They likely fed on the decaying organic matter that was just beginning to accumulate on the damp edges of continents. This was a momentous step. For over 3 billion years, life had been confined to the water. Now, animals were walking on dry land, breathing air, and beginning the long process of colonizing a whole new realm. Of course, these animals could not have survived without a food source. The first land plants were making their own tentative journey out of the water. Initially, they were simple, non-vascular plants, like mosses and liverworts, that had to stay close to water to survive and reproduce. But during the Silurian, the first vascular plants evolved. A tiny plant called Cooksonia, just a few centimeters tall, developed rigid stems with internal tubes to transport water. It had no leaves or roots, just simple branching stalks topped with capsules that released spores into the wind. This was the beginning of a greening of the continents. This new terrestrial ecosystem was a partnership. Fungi spread across the land, forming a symbiotic relationship with the fledgling plants, helping them draw nutrients from the primitive soil. Some fungi, like the bizarre, pillar-like Prototaxites, grew into massive structures, perhaps up to 8 meters tall, towering over the tiny landscape. The Silurian, then, was a period of fundamental transition. It built the first complex marine reefs and established the dominance of fish. But most importantly, it saw the first brave steps onto land, a move that would ultimately lead to the forests, the dinosaurs, and eventually to ourselves. The world we know today truly began here.